summary box. Steps for solving a linear equation. Step 1, most people don't ever do this. List any restrictions on the variable. That's because you just don't think about it. But if x is undefined somewhere, then you probably should make sure you're aware of that, because you might have to throw out an answer. Step 2, if necessary, clear the equation of fractions by multiplying by the least common multiple of the denominators of all fractions. That means if there's x's in the bottom, right, we want to simplify it first. We'll do something like that today. But usually for us, we start at step 3. In ECA lab, I start at step 3. If you see parentheses or anything you can simplify, do that first. Collect all the terms with the variable on one side and the other numbers on the other side. Simplify and solve. Check your solution. Most of you never do that either, but it's a really great step because you can check to see if you're right. All right, you ready to start? You're going to be so excited about this first problem. It's super easy. You're going to be like, really? This is my first. She's in the computer lab. Angel said, she's typing her vocab. Okay. You don't have to write this down, Bobby. Just linear equations. We'll have to write. Here we go. Oh my gosh. My smartboard just shook because the lawnmower just hit the wall outside here. That's ridiculous. I feel like they switched your product. I think the lawnmower was like rolling away as much as they did. Just sharpen the blades and yeah. Why are you? I wrote on myself with ink and I'm trying to use hand sanitizer to get it off. Aaron, did you write this down yet?
Yeah.
Come on, we have lots to do today.
She didn't even tell me good morning. She just said, I think so.
So, T, sometimes my T's look like plus signs. I like to make my T's look like this. To solve number 1, we have letters on both sides of the equal sign, so we need to get our T's on the same side, yes? So guess what I'm going to do? I'm going to add T to this side. And if you're feeling really fancy, you can go ahead and add 6 together. Aaron, what would I do next to solve this equation?
You would add 6.
Because I want to get T by itself. So I'm going to undo addition subtraction before I undo multiplication and division. Then to get T by itself, to undo multiplying by 3, I'm going to divide by 3, and I'm going to get that T equals 3.
You gotta check your answer.
You don't got to show me you're checking your answer, but you can plug 3 in there and make sure that it works. And I think it does.
6 by 6 is 0.
So if you feel kind of okay on number 1, go ahead and try number 2. You need to distribute first. Because I'm hoping you're feeling excited, like, oh my gosh, I can't believe this is what we're doing now. I love that. Nathan Chris sent me a message on Facebook that said my first day of calculus, and it was a slide that said order of operations. And I said, seriously, you're learning order of operations in calculus class? He's like, well, it's survey of calculus, so it might be a little different than regular calculus. Like, if we're learning order of operations, then it's got to be different. But
I think that class. Order of operations. But I want to ask you this. I'll get my 6 credits here.
I had to take college algebra in college. Like it was required for math teachers to take this class that was college algebra. And seriously, every day I was like, I'm seriously solving equations and factoring. Like, I'm going to be a math major. This is my first math class. And then by the time I graduated, math majors weren't required to take that class anymore. But this was my first class, and it was.
I'm glad you're on the bill.
I took calculus my senior year of high school, so it was kind of silly for me to take this class, but that's what I had to do. I'm going to go, all right? I'm going to explain it. You tell me if you disagree. And then remember, you have options. You can move the 2x over here, or you can move the 3x over here, whichever way you want. I like positive, so I'm going to add the 3x. And since we are advanced people, if you wanted to, you could go ahead and add the 1 at the same time. So you could say 7 equals 5x. And then remember that we're not scared. Did you miss this? What's wrong? Okay. That's why we were laughing here. It's okay to get fractions, okay? So don't freak out about that. In ECA lab, they always freak out if they get fractions. 7/5, if you want to say that's 1 2/5, 1.4, but really 7/5 is the best answer. Questions about that? So not all the simple. We're just starting with the easy ones.
See, I always, even with these simple little ones, I just feel good about myself when I get that final answer.
I always feel like self-conscious. Like I feel like I didn't do it wrong.
Right.
And it's more like a sigh of relief if I get it right.
Oh man, okay, they're getting a little crazy.
Oh man, this is how it works every time.
Anything?
On number 3 here, again, you have more than one way you could do this problem. One way you could do it is just deal with the fractions, especially because you have a calculator that has a fraction button. But I hope that you realize that you can make your fractions go away in an equation because we could just multiply by the common denominator. Look, I got a pen over here and a Sharpie pen. What would be the common denominator of these denominators here? 6, right? Because there's a 2 and a 3. So if you wanted to make this easier, you could go through and you could multiply everything times 6. Because if you do that, it'll cancel out your fractions. Okay, that's my advice to you. If you see a fraction, that's what that step 1 said, that multiply through by the common denominator. Well, that's really what I'm doing because I can cancel, right? Like if I cancel the 2 with the 6, that's just going to be a 3 left over, right? So you multiply by the common denominator because you have to do the same thing to everything. But I see what you're saying. Like you're saying just multiply by what's missing. That's what we would do if we were getting a common denominator. I'm trying to cancel it out. So if I multiply this, look, I'm left 1/2 times 6 is 3. If I multiply this by 6, I can cancel that out. 6 over 3 would give me minus 2p. And over here, 3 goes into 6 2 times, and I would get 8. So instead of getting a common denominator like we did when we were adding and subtracting, because it's an equation, we can just cancel out the fractions and have no fractions left. And then look how much better that problem looks, right? So just remember, if you see fractions, you can multiply through by the common denominator and get your answer. Just watch your negative signs. I said that's the biggest mistake that people make in solving equations all the way through calculus is their negative signs. So that's a positive 3. So I'm going to subtract 3.
I already have the answer.
I got negative 5 halves there. Did you get negative 5
I
halves?
think it's negative 5 halves, but I just don't know.
Fix your advanced calculator.
That was fine.
You can tell the calculator. I see it on the calculator.
Actually, that was my checkers answer.
Hmm.
Step
No,
one.
it's not really calculated.
Don't tell me lies.
No, it really was checkers. I do quizzes. I do quizzes.
So, we was speaking or kind of had a discussion over like sweaters and how, you know, how they have little balls underneath behind a sweater shaper. Well, I had never heard of the actual shaper itself. But I just always thought, like, I've heard like the pumice stone trick, where you take a pumice stone and do the same thing. But I never heard about the sweater shaper.
I don't think I've ever been a sweater shaper.
No one's ever heard of sweater shaper. It's like, it's just the only way to talk about it.
Does she have one?
Yeah, like it's like a, you
Just
just,
bring it in and show us. And it like cuts off all the things.
yeah, but did you know if you like a sweater?
Oh yes, it's terrible. Like I stopped wearing that at some point because then they're just
No, like you
goes
go, I
off.
guess you turn it on and then it shaves all that off, but I never heard of that. I heard of pumice, you just take a pumice stone.
I've never heard of either one. You just taught me 2 tricks today. Nick, what do you think we should do first on this one? Yeah, I think we need to work this out, multiply all this stuff first. So, FOIL this, we're going to get x squared minus x plus 7 parentheses if they're in your problem, whether it means distributing, whether it means FOILing, or multiplying. And then I'm just going to combine like terms, because I think the less stuff you have, the less mistakes you're going to make. So I never start moving stuff around until I combine like terms. Negative 1x plus 7x is 6x. And on this side, I'm going to get 2x in the middle. Anyone have a question on where I'm getting that? No, we got to solve for x. And so since this one, if we have an x squared on both sides, and we subtract that x squared, that's going to cancel out, which means it's still going to be a linear equation. Right? So we don't have to think about factoring or anything right now. Copy.
Is there a way that what I did is I noticed that both sides have x squared and x, so I subtracted x squared minus 2x.
So yeah, you can do all the stuff at once. Like I'm okay if you move a bunch of stuff at one time. Like notice I'm going to do it all at once, just a step at a time. But I'm going to write it all in one line. Because I see that I'm moving my x's over here, so at the same time I'm going to add 7 to the other side. And I'm going to say x equals 2. Did you get x equals 2?
Yes, we did. All three of us.
So far so good? Moving on.
Another funny thing, I was trying to be all smart doing it myself, and I foiled it all out, and then I
Factor it back. So that. That's it.
Can you show me how the rest of it?
Not right now. Oh man. Aaron, you better write this down. It's getting more exciting. So this is why we did R7, which was adding and subtracting rational expressions, to remind you about common denominators, all that fun stuff. Just like the problem that we did that had the 2's and the 3's in the bottom, and we multiplied through by the common denominator, we can do the same thing on this. If you can figure out the common denominator, you can multiply everything by that common denominator and cancel out your fractions, which is what you really need to do. The other option, I guess, would be to get a common denominator and leave it all as fractions. But factor first. Like on this one, can I factor this into x minus 3 and x plus 3? Cross that out. And the same thing over here. X minus 3 and x plus 3. And that's so what would the common denominator be for this whole big problem? An x plus 3 and x minus 3. Because if I do that, then that's going to fix all of them. So if you find your common denominator, I'm going to say LCD up here. X minus 3, x plus 3. Instead of just getting a common denominator and multiplying by what's missing, because it's an equation, we're going to multiply everything by that common denominator. And what should happen is the fractions cancel out. Most people just kind of do the shortcut in their head and multiply by what's needed. But I'd like to show you why this works, all right? So if I multiply everything by x minus 3, x plus 3, x minus 3, x plus 3, x minus 3, x plus 3, right? You have to do it to everything. All the denominators should cancel out, and what's left should just be a nice linear equation that you can solve. So this cancels out, you're just left with x. Plus, on this one, only the x plus 3 cancels out, yes? And I'm left with 4 times x minus 3 equals, this cancels out, I'm just left with 3. I know that the majority of people, what Courtney was saying on the last one, why don't you just multiply by what's needed? And that's okay, as long as you get the right answer. I just like to show you what, the reason the fractions go away on the bottom is because you're actually canceling all those out. So, as long as you get that, I don't care if you kind of do your own little shortcut there. And again, now it shouldn't be that bad to solve, as opposed to where we started with.
Amen, brother.
What it is.
Oh.
to think about what x can't be. Look at those denominators. Can I have 3 in the denominator of that problem? No, because if I plug 3 right here, 3 minus 3, I'm going to get 0 in my denominator. This is an extraneous solution. So this is one of those that you don't have to actually check your answer and like plug it back in. But when you have x's in your denominator, you need to look back and say, does that make it undefined? It does. So although we got 3, we get 0 in the denominator when we plug that back in. So we actually have to say there's no solution to this problem. After all that work, we get no solution. So check your answers when they're next to the denominator question. Here.
So I had to take this test,
my God,
this
that's
math
really
test in JAG, and there was this like remainder stuff,
Yeah.
and I don't remember how to do it. Like I barely remember. Yeah, we finally got a teacher. She's pretty good. She got really good math. She had a big heart. Who are you talking to?
It was kind of like the last one, except for what? What's different? There's no common factor, which means what would your common denominator have to be on this one? All of those. Y plus 3 times y minus 4 y times y plus 6, which means we need to do a whole lot of multiply. And this is where people say, well, I'm just going to multiply by y minus 4 and y plus 6 because you kind of know in your head that that's going to cancel out, and I'm okay with that. But because there's so much math, there's so much room for little mistakes, so that's why I always say show your work. So maybe I can look and see what happened if you don't get the right answer. Who loves to foil?
Everybody loves it.
So you have options here. You can FOIL first and then multiply the number in, or you can multiply the number into one of the parentheses first and then FOIL. I don't care, but you just got to pay attention to what you're doing. So I'm going to FOIL first and save the number on the outside, put that in at the end. And I'm going to combine my like terms at the same time. So we'll see if we agree or not. Plus 6 minus 4. Oh my God. What's 18 times 3? 54? I think this line right here that I just finished, no matter how you multiply or FOIL, that should be what you get before you combine like terms.
I just did.
This is the difference between calculus and this class. Calculus is a whole lot more granular, and you write like 7, and you just write 7 on the paper. And this one is a whole lot of multiply. Combine like terms, FOIL,
All about life.
take it slow. Take it slow. Oh, Aaron, how do you switch that over? And again, remember, equal sign kind of separates squared on both sides. So I'm going to add 5y and get 36y plus 6 equals negative 60. Subtract 6. Can somebody else get this? 36y equals negative 66.
Ideally, random
I did not get that.
Divide by 36.
Oh, I see what we did.
And that would be negative 11 over 6. Barf. At least it's not no solution. I can't read this. I can't read this chicken scratch. Look how small that is. No, that should be a 4 or a 2 bar. What? 12 minus 8. That's 4. Yes. And that's not right either. That's not 15y. That should be 27y. What?
I feel like she does, and he is the same life. You guys know that. It's like
What does he do? Like, what's his profession?
With my husband and I, he was no, he doesn't. The man ain't perfect. Back in the day. IU West Hospital. But he went back to college after I was a teacher, and so he was taking all these math classes, and I was a teacher, and so we discussed it then, but we don't really sit around and do math that often. We'll talk about it. So he works at IU West Hospital. He's a, I don't know, clinical engineer is what they call it, but basically like he does all the preventive maintenance on all the machines from like thermometers to the CAT scan, the CT machines to the sterilizer that they sterilize all the equipment for. All that stuff, if it breaks down, then they have to go fix it. It's very, I feel like it's a very hard job to like you pretty much just learn as you go because he has a degree, but you have to learn each machine separately. And so sometimes it's as simple as they have to replace the batteries on the thermometer, and sometimes it's like the valves are not working on the sterilizer. And it's very crazy job. So we don't really talk about that much. But just about this stuff when he was taking these classes. Okay, don't write all this down, but write this down. Number 85 from page 91. And then you can maybe write the basics of it if you want. I will tell you on your unit test there are story problems because they want you to be able to take this idea, solving equations, and apply it to story problems. So it says, Sandra, who is paid time and a half for hours worked in excess of 40 hours, had gross weekly wages of $442 for 48 hours worked. What is her regular hourly rate? If you want to write something down, I would just write this. $442 for 48 hours. And you could write down what is her regular hourly rate if you want to. But that's giving you the information. And if you need to go back to page 91 to look at this problem, guess what? You're going to do like either 90 or 92 on your homework tonight, so it'll have it right next to you of which problem this was. You could probably guess and check eventually and get this answer, but most of the time people don't make like it's weird hourly wage that people make. So guessing and check I don't think is the best answer. I think writing an equation is the best answer. She is paid time and a half for hours worked over 40 hours, which is usually what happens. I'm going to call how much she makes her regularly hourly rate. I'm going to call that X. You can call it whatever you want. R, W, whatever. Smiley face. How would I show how much money she made for working 40 hours? Same question. Go. She worked 40 hours at regular pay, we would say 40x. Yes? Plus, how many hours is she going to get overtime for? 8, because she worked 48 hours. How can I show time and a half if she makes X dollars regular? Time and a half means she makes her regular wage plus a half more of her regular wage.
So I was right.
That was right. Or, think about, that's just 1.5 you made $10 an hour, how much would you make at time and a half? 15. It's your normal rate plus half of what you make, so that'd be plus $5 extra dollars. So 15. Right? That's time and a half. So, what should that equal? 442. Because that's how much she made for working 48 hours. Aaron, stop talking. I'm going to go ahead and add these together. Time and a half is like 3 halves x 1 plus 1 half. Or you can just distribute. I don't care. You're going to get the same answer. 1.5x, that's time and a half. Hopefully the hard part of this was setting up the equation, because now all the x's are on the same side, and you can use your calculators and decimals, I don't care. But this would be 12x, 40x plus 12x, which would be 52x. We're talking about hourly wage here, so your answer should make sense. She shouldn't be probably making $100 an hour. She probably should be making more than 72 cents an hour. Does that work? 442 divided by 52, 850. Does that seem like a reasonable hourly wage?
Makes a dollar more than that.
I make more than her.
That's another make. Nick, what do you want?
Much higher.
Starting
I
line.
think I have one more short problem, but I think I might just give you homework and we'll just talk about it tomorrow if you have fun homework. We only have 4 minutes till the bell rings. Oh my gosh, time flies. This is homework 1-1. We're only spending 1 day on this. I'm trying to give you a variety of problems. So there's a decent amount of problems here. 21 through 33, multiples of 3, right? Every third problem. Okay, so that's 11 problems, and then 86 and 88 are story problems. So that's not so bad. 13 problems.